Hi everyone, and welcome to IoT in plain English. My name is Michael Garcia. I've been working at AWS for the past 5 years, and I'm a senior technical program manager in the IoT team. And today I'm with Brett. Brett, could you introduce yourself?
Hi, Brett Francis. I'm a principal technical program manager in the IoT department as well.
And today we're very honored to host Tom Soderstrom, who is the IT Chief Technology and Innovation Officer at NASA JPL, and Mick Cox, with the team lead for Internet of Things at NASA JPL. So today we wanted to share with you a few things, a few tips, so you can be successful when you're going to start your first IoT project. This is a 200-level session, so it's really an introduction to IoT. And we also wanted to talk about all the new services that has been released yesterday morning during the Andy Jassy's keynote. So you can see how all those IoT services are fitting together. Then we'll have Tom and Mick on stage, and they're going to talk about what they're doing at NASA JPL with IoT. And then at the end, we'll also see IoT in action with a video of a demo. Who has been in the State of the Union IoT session yesterday? Okay, a few of you. Nice.
So what we've seen this past year has been quite exciting and interesting. In the Internet of Things, what we've learned from our customers is that there's this inherent volatility in operating these devices out in the world, which I'm sure many of you know if you've touched these things. But it also pairs well with something that we're learning from our customers is they're increasingly using serverless technologies alongside this volatile front door, this volatile set of devices that are out there. And it's because the needs for scale that go up and down, or the elasticity inherent in an IoT system, is a really good fit with serverless. But one of the things that's actually happened a lot more this year is, in addition to the Internet of Things being paired with some serverless capabilities, there's an artificial intelligence, machine learning thread that's starting to make its way in to these solutions as well. And it allows the system, once it's up, to actually kind of evolve and improve over time, which has been quite exciting. So we've seen a ton of different capabilities that our customers are doing this past year. Michael, is there any one in particular that kind of stood out for you as the coolest?
Yeah, there is one that I really, really liked, and you can see, all those technologies coming together at the same time to tackle very, very important business challenges, and here it is. So as you can see, the business challenge here is to make the fish move. So there is a camera above the fish tank that is detecting where the fish is headed. And if the fish is heading forward, then it moves the wheel, and then the fish tank can move forward. So I, for one, am very excited to see that IoT and those technologies will enable fish to, go and explore the world on their own. But most sincerely, though, the reason why our customers are doing IoT on top of AWS is because they can delight their customers with products that are ever evolving. If I take an example, let's say you buy a car, and with a tank full of gas, you can do 200 miles. Then 6 months later, there's going to be a software update that is going to make the car more efficient. And now you can drive 220 miles. So of course, for the customer, it's only natural to see that, this product is evolving, giving more benefits. So you would have better relationship with the brand that manufactures that product. It's not only a benefit for the end customers, it's also a benefit for the companies who are manufacturing those connected products. The reason is that will enable them to set up a culture of data-driven inside their company and make a decision business based on data. So again, to continue with the car example, let's say that you design the door for being open 100,000 times during the lifetime of the car. And now you have all this data flowing back to the cloud, so you can actually see that the real number of times, in the cycle of the lifetime of the car is only 50,000 times at maximum. So maybe that means that you can redesign those doors to save cost on materials because they don't need to be as durable. And then you can, with the cost that you save, inject that into areas that are more meaningful for your customer. So again, being more efficient in that way. We've seen customers as well using IoT as a way to create new services and business models. But the bottom line is that IoT will enable you to grow your revenue and also be more efficient from an operational standpoint. So I've talked about customers. Brett, could you tell us in which categories those customers are?
Yeah, so we're working with a lot of different customers, and at a very high level, you can think of the customers we're working with in some big categories of industrial, commercial, and consumer. But this capability that spans all of them is really related to this kind of ever-evolving set of solutions and products. So you can imagine in the industrial space, if you have a manufacturing line, that day one, your robot arms and the whole thing are operating at a particular level of efficiency, and overnight, as the data goes up, gets processed by machine learning or something of your own statistical analysis, and then the algorithms come back down for those robot arms in your in your manufacturing line, that they get better the next day. Even 1% in some of these cases is pretty significant, and that round trip, that behavior of going to the cloud and back, detaching, attaching, is something we see across our customers in these different segments. So in the consumer space, you might have a wearable device that has a similar behavior of the capability got better the next day. Or in commercial, let's say an MRI machine had a new software update, but not just software update for it, but its fundamental intelligence got better because of its integration with the cloud and some of the capabilities that are out there. So these things are all across industries. But instead of thinking of the customers in terms of the industry names, what we're finding is it's actually more valuable to start at the workload and work backwards from there. So if you have this workload that's out there, it's fundamentally going to be this complex and multidimensional thing. It's going to start from devices and sensors that go and connect with the sensors that are out there. They're going to communicate into your cloud. There's going to be the connectivity infrastructure that you're going to have to work with. There's then the analytics and insights that are the beginning of where some of your business objectives can start to be met. The insights that come out of your analytics and insights will then flow into the corporation or out into applications that the customers might be using. And then all of this needs to be wrapped up in a mechanism to perform change management over this, so you can actually improve these services and capabilities to your customers over time. Do you want to talk us through a couple of these categories?
Sure, we can take an example in the connected transport use case category. So let's say you have a connected bus, connected forklift, a connected boat. Surely they will have attributes that are specific to each and every one of those vehicles. But they will also share a common set of attributes. For instance, because all those assets will be moving, you're going to be interested in the speed, no matter which vehicle it is. There's also going to be a set of protocols that you will encounter when you're deploying your projects, and those will be the same as well in that use case category. For example, if you're talking about cars, you've probably heard of the CAN bus or ODB2. Now, if you want to connect those assets, it's also going to be shared because those assets are moving, so you cannot use a wire. You will have to turn to wireless and cellular technologies that are long range. So for example, 2G to 5G or NB-IoT and the likes, or connecting it with satellites. If I take another example in the connected space this time, it's the same thing. If you connect a house, if you connect a building office, if you connect a government building, they're going to share some attributes. Imagine you have solar panel on the rooftop, or that the building is producing energy somehow. The attributes that are going to be the same are the voltage, the amperage. You will also have thermostats in those connected space. So temperature is one that will come all the time. Regarding the protocols, in the industrial space, you've probably heard of Modbus and BACnet. And now to connect those assets, this time they're not moving anymore. So you can actually use Ethernet to wire and bring connectivity to those space. And inside those connected space, now you need short-range wireless technologies to connect all the sensors that would be in a room. So that would be Wi-Fi, Zigbee, Z-Wave. So you can see that those use case category, they are spanning industry vertical, and they all share a common set of attributes. So that's why it makes sense to group them. I've talked about two of them, but I believe there is more, right, Brett?
Yeah. So if you take this key dimension approach, that we're seeing our customers use, it reduces that complexity of the overall solution, but it also gives you a way of kind of grouping these capabilities together. We found a lot of value in this, as I mentioned, starting from that workload and working backwards, because then imagine you have an automotive manufacturer that at the highest level, they're a manufacturer, so they look like they're in this industrial space. They have a manufacturing line that's a connected manufacturing, increasingly, that they're producing cars with. But what they're actually producing are connected vehicles, which in this case would have a slightly different behavior and a slightly different solution dimension that is more important than the others. So by thinking of this workload approach, we're able to actually engage and help customers better, as well as understand these things better, to give them guidance to get them to the outcome that they're seeking for their business faster. So there's connected spaces we're learning about. There's connected transport we're working with folks. There's connected operations, connected health, and connected commerce, and a few others that we're still engaging across all of our customers as well. But this approach has actually been quite powerful and quite interesting, because it has also shown us, under the covers of all this, a set of 3 pillars, which if you're at the SOTU, you might have seen this as well. But we actually, we didn't just put this out there. This is actually something we've learned, and the depths of all of our engagements with customers are truly 3 pillars that span all of the different segments that we're working with and all of the different workloads. So you have devices, you have cloud and intelligence, where the devices across these use case categories are sensing and acting. It's pretty straightforward. The cloud is there for orchestration, for storage, for compute, for bringing together and allowing the connectivity to take place in a way that's very powerful across the globe in many cases. And then you have intelligence that layers on top of that, where the logic and the data that comes from the system can actually be put into action or into those business objectives that usually drove the original project in the first place. So then, thinking of that, we've had, until yesterday morning, there were 2 services that we offered up in these pillars. One was AWS IoT Core, about the connectivity to and from the cloud for these devices, and then AWS Greengrass, which allowed portions of the cloud to actually extend and detach and operate on a local gateway on the edge. So there's been a few new services that have come in as well. If you're at the SOTU, you saw those, or in the keynote. Micah, you want to take us through some of those?
Sure, and now with those new services, so starting on the devices side, you've seen the announcement of Amazon FreeRTOS. So now you have the ability to connect microcontroller to the cloud or to AWS Greengrass. On the cloud side, with AWS IoT Device Management, you can manage a fleet of millions of devices at scale. We're also giving you a new tool for security, that is AWS IoT Device Defender, so you can make sure that your fleet that is in production remains secure over time. And as Brett mentioned, it's all about the business outcomes, right? You're doing this project for a reason, and that is to tackle some business challenges, and that's where the intelligence part comes in. So it's the business logic, but also all the analytics, and that's where AWS IoT Analytics comes in. And then there's another service that you can use if you want to get faster to that last part of processing the data. With AWS IoT One-Click, you don't have to manage the hardware. AWS or a partner will build it for you. Then you don't have to manage as well the onboarding and the provisioning of those devices. You only have to write the AWS Lambda function that are going to be triggered and take those messages as inputs, so you can start right away and create your IoT application. So now we wanted to dive a little bit deeper and make it a 200 level session. And for that, we wanted to share with you how all those services are fitting together. And we thought that going through the use of personas to put ourselves in the shoes of the people that are going to use those services was a good idea. And I believe the first one is the device engineer.
So how many folks in the audience are embedded developers or have some device development? All right, so a few. Okay, so those folks, they constantly live in a world of resource constraints. So there's challenges that we're seeing across customers, either where they have the device engineer on staff or they need the device engineer skill in their company to build an IoT solution, is overcoming the constraints and the issues with building microcontrollers or very small devices that need to exist out in the world. There's some other challenges we've seen in that space as well, and there's inherent challenges in, if you're building a new device and you're making it unique for the task at hand, then the ability to connect that device into the cloud oftentimes is something you have to write yourself. Literally have to write some of the communication protocols, or you have to go and choose a package from somebody else and then decide if it fits exactly the device that you're making uniquely, versus the general computing world that the mobile phones in your pockets developers get to deal with. So this acquisition of technologies, this packaging of those technologies, then is wrapped with the ability to secure those bits as they're moved to the device, and to secure those the bits communication with the cloud. And all of that is this behavior and challenge we've seen across industries, and it's fundamentally why we actually went out and released Amazon FreeRTOS yesterday morning. And for those of you that aren't aware, RTOS stands for Real-Time Operating System. So FreeRTOS is the leading RTOS that's out in the world that many folks develop microcontroller applications with. Amazon FreeRTOS extends that so that it has off-the-shelf capabilities that can be packaged. You choose them or you don't. So you go into the console and you pick a list of the capabilities that you want to actually be used in your software package. So it overcomes that finding challenge. Then the connectivity capability is built by us on top of FreeRTOS itself, so it overcomes the challenge of having to do it yourself. And then the last part is there's the security. The delivery of this package to the device is something that's built into the service, but it also is able to update itself on the microcontroller devices as new security concerns or constraints come about. So you want to take us to where that fits into an architecture?
Sure. So now that you are using Amazon FreeRTOS, you're going to be able to connect your microcontroller either directly to the cloud, to AWS IOT core, or locally to an AWS Greengrass core that is deployed next to your sensors. Either way, all the data will be able to flow to the cloud. And now that we have all those objects that are connected, and we're talking about a fleet of millions of devices, you have to manage them. And the person that can do that is the fleet manager. So the fleet manager has an intimate knowledge of the fleet of devices. He knows the hardware, he knows the attributes of the hardware and what the devices are doing, and is on the hook to make sure that the fleet runs smoothly, that updates can run smoothly, but also to monitor the health of the fleet. So of course, to do that, you will need a few tools. And some of you, if you have used AWS IoT Core before, you're already familiar with device registry, where you can store metadata associated with your devices. So for example, a car, I would be able to stock the model and the year of the car. And also device shadow, where you have attributes that are most related to the data that is produced by those devices. So as a fleet manager, I can use AWS IoT Device Management, go into the console, and now I have this new search bar that I can use to run query of my fleet and create new groups of devices. So now, for example, I can create a groups of cars that have been built in 2015. And let's say now I want to run a job on my fleet. So a job is very generic. The implementation is up to you, so you can make it anything you want it to be. But let's say it's an update of the firmware. In that case, it means that as a fleet manager, I can really target only the group of device that I want to. So I can push that job to all the cars that were built in 2015. Let's say now, because jobs are generic, another good example of usage that we've seen is to run full diagnostic, for example. So now I want to target in my fleet of cars all the cars whose engine has been started more than 20,000 times, because it's a lot of time. I just want to make sure that all those cars, they're still running smoothly. Well, same thing, I can push a job, and then the device will run the full diagnostic and then send the data back to the cloud, and now I can analyze that, process it, and make sure that everything is running smoothly. So Brett, can you tell us how does that fit into the architecture?
Yeah, so we have now a new additional capability in the cloud specifically. So once you have the device management, now we have the ability to onboard devices, heterogeneous fleets of devices, so they can be Amazon FreeRTOS based, they can be Greengrass based, or they can be any solution that then fits into the ability to manage the fleet. And now we're starting to get to the point where the information from this system starts taking precedence from a persona perspective. So the information that was ultimately there to be gathered up to support these business objectives is in the realm first of the data analyst. So the data analyst has two sub-capabilities that we've seen across companies where it breaks into the data analyst needs to know enough about the dirtiness, the grittiness, the inherent challenges of processing the data that are out in the world. There's gaps that come about, there's sensor misreadings and everything else. So the data analyst needs to know enough about cleaning that data in order to make it structured enough to then create and deliver reports into the business and or to meet the direct business objectives that were there. So the data analyst kind of straddles both worlds. They'll tend to work with the device engineers and the fleet managers, but then they'll also work with the rest of the interested parties across the company. So they have some interesting challenges that then we feel IoT Analytics meets directly. So you go into the console of IoT Analytics, and there's a portion of the console which is all about ingesting, collecting, processing data from multiple sources, keeping the raw around, but starting to add some structure to it. And then once you do that, when you're processing it and filtering it, you want to enrich it. So for example, if there's humidity data, you might want to enrich it with weather data. So alongside each other, downstream in your processing flow, you can make some decisions based upon correlations in time of humidity versus predicted rainfall. Once you have that, then the data analysts will need to store it and then kind of flip into this other mode where they start the beginning of the creation of reports or data set delivery to the rest of the business, either the data scientists for machine learning or things of that nature that want to take place, or just to flat out reports and charts and graphs. And that's then where IoT Analytics itself fits in with our own services such as QuickSight and Amazon SageMaker, as was also introduced. But it can also fit into any services and enterprise applications that our customers are using. So you want to tell us a bit more about that?
Sure. So now we have this fleet of devices. We have data flowing to the cloud. We can funnel that data to AWS IOT Analytics. And wanted to share with you, now that we have this high-level view of all the service fitting together, what does it mean for your first IoT project? A good thing to start is always to look at the data. Again, if you start a new project, it's going to be about why you're doing it. So once you have a look at the data, you can talk with other people, executives, product manager, to find business model around your IoT application. And you will see that over time, people are going to ask you more questions. And either as a data analyst, you will have the answer, or you will need to speak to the device engineer to ask him if he can add more sensors, for example, to gather new data. Or that can be just a software update. So now you can send out new metrics to the cloud. So let's say that we go down the path of making a software update. The device engineer now will talk to the fleet manager. So of course, the fleet manager can roll out the update on only 1% of the devices that you have in production just to test it out. But thanks to his intimate knowledge, he will be able to figure out for you what is the best group of devices to be tested on. And you can see there that there is a loop, right, between all those three personas. And only when you close the loop, then you can really go to the business outcomes. So it's important that all those personas in your company, that can be one person, that can be multiple person, but it's important if it's multiple person, that they collaborate and that they talk together. Why? Because the speed at which you're able to do this loop, it's actually the speed at which you're going to be able to make your IoT application evolve. Mm-hmm. So you want to make that as short as possible and iterate as many times as possible. So it's very important from an organization point of view. And you can see now how the two line up. So security is a top priority at AWS, and there is a persona that is looking after that, and that's the security engineer. Brett, could you talk about the security engineer?
So how many folks in the room have security somehow under your responsibility? All right. So when it comes to IoT, there's the inherent capabilities of any IoT solution where you can create and provision the devices to include certificates, credentials to allow those devices to communicate in with the cloud and your solution. There's then the policies you can put into place to allow those devices to behave in the right way as they're a member of your fleet. There's the capabilities of the data that came from it and the security around that data to then flow into your business. But a lot of this tends to be done ahead of time before the devices get out into the field. What we're seeing is the challenges for the security engineer in IoT systems. Oops, let me go back one. The challenges for the security engineer in IoT systems is just as much related to after these systems are deployed, after these devices are out in the field. And in fact, many security vulnerabilities are discovered after. So if there's an operating system in the mix, there's changes that need to be done and patches that need to be applied. So the security engineer tends to then run around and work with the three personas we had earlier to determine what can be done and what can be detected in the devices, work with the fleet managers to roll out jobs, et cetera. And it tends to be a very challenging capability to then keep up with the state of security of the entire fleet, particularly as those fleets grow. So this specifically is why we introduced AWS Device Defender, is having a secure fleet is fundamentally good for all of us, but the service itself is there to help the security engineer role to monitor the fleet and detect and audit the information that's coming from that fleet. In Device Defender, you can also leverage the off-the-shelf best practices policies that we have, or create your own. So you might have unique devices, unique chipsets that have unique security constraints and considerations that you can then have Device Defender use the policy related to those to monitor and detect any anomalies. And once the anomalies are detected by the system, then the alerts can go to human beings, so the original security engineer or security engineers. It can go to SNS, it can go to CloudWatch, and it can also go to device management, so for mitigating actions. So let's imagine that you have a fleet of 1 million devices, and 2 devices are detected to have non-compliance with security patches. So for whatever reason, even though everything went out and looked like it completed when you managed your fleet, now a short time afterwards, it seems like they're not actually patched in the way you would expect. So now there's 2 things you could do. You could imagine that Device Defender would detect it, report this to somebody. The somebody would say, great, let's fire a job to repatch those. Or let's say that goes on, and then a day later, the patch is still not quite taking hold. So now what you might want to do is actually take those 2 out of your fleet and remove their credentials whatsoever, so you can go investigate them with a different process or practice. So when you have all this, you're now at the point where you've got microcontrollers, gateways, heterogeneous fleet that's under management. Now they're able to be managed and secure, but let's say you wanted to get to this point a heck of a lot faster, and you just wanted to skip as much as you could, and that's then where the next thing Michael's going to talk about fits in.
So to be faster, that means start already, if you remember the 3 pillars of IoT, at the intelligence part. So again, if you don't want, for the people and companies that don't want to manage the hardware, that takes care of the firmware updates and all that, you can use AWS IoT one-click. So with a persona who is a cloud developer, this person can leverage the messages that are coming from simple devices as a trigger for Lambda function, and then do all the processing they want and create their IoT application. And the way it works is that you will get this hardware. So at launch for AWS IoT, one-click, you will have the AWS IoT button, and a button built by AT&T that is connected with cellular technologies. And is also certified IP66, which means you can put it outside, and even if it's raining or there's water going on, it will still continue to work. So a simple use case would be, for example, waste management. Let's say you're on a construction site. There's a big container where you put waste in it, and it will start to fill up. And once it's almost full, you can just push the button that is next to it, and then a truck will come and get that. So everyone can continue to work on the construction site. So for that, you only need to go into the Lambda console. You're going to create all your Lambda function. And then going into the AWS IoT one-click console, you will just link those Lambda function to the devices you want, to the buttons that are in the field. And in that console, you will already see that you have a number of devices that are out there. You will also have dashboards with metrics that come out of the box because, again, it's a managed service. So all the onboarding and provisioning, the certificate are placed onto those buttons and manufacturing time, so you don't have to worry about all that. So if we go back to the statement at the beginning of the session, you can see that now you have all those IoT services that you can use, the ones that were just released, and also new intelligence, artificial intelligence services. For instance, we also released on AWS Greengrass the ability for you to deploy trained machine learning model coming from SageMaker right to the edge. Every customer that we see deploying IoT application, of course, you will have to use one or more IoT services, but you will also make use of the rest of the AWS cloud. So we showed you at the beginning the project with the fish in the fish tank. Let's talk about example of projects that NASA GPL is implementing today, and for that, I'm going to welcome on stage Tom and Mick.
Good job, thanks.
Like I said, space is serious business. Thank you. So we had 18 spacecraft, but Cassini committed suicide. Very well done suicide, by the way, assisted suicide. So we have a lot going on. It's a busy time, lots and lots and lots of data. 2 of these spacecraft that I'm showing now is generating 100 times more data than everything else we had put together. So cloud computing, we started playing with it, and I say playing on purpose, about 10 years ago. So we've been doing cloud computing for 10 years. It's a good thing, because now we really need it. So today's toy is tomorrow's tool, but you don't know which toy becomes a tool until you play with it. So to me, IoT stands for Internet of Toys. And which toys are going to become tools? So here you're going to see some things. We're going to have a busy time coming up. Lots and lots of new things in our IoT network. And you can see what's going on in real time. This is very different than it used to be, where you'd have to get access and permission. We now want you to use this data all the time. So here is a new one. And you're going to see a video in a little bit where a rover that looks similar to this. This is the real deal. This is Mars 2020, yet to be named with a better name. It's going to go up to space, and it's going to have new instruments. It's going to be able to make oxygen. Could be handy when we go there. It'll have bigger wheels, be able to climb up steeper things. We'll have microphones so we can hear the sounds of space. And it's going to cache a sample that future astronauts, or actually robots, will pick up. It's going to have a little buddy, a little Internet of Toys thingy. And that's a spacecraft, it's a helicopter. So that helicopter will ride along, and it'll pop over the hill, take a look, and tell the rover, yes, it's worth going there, or no, it's not worth going there. So what is that? It's automation, it's AI, it's Internet of Things, it's communication. It's all of the things that we're talking about in today's Internet of Toys. So how we're going to make that work? How do we infuse emerging technologies at JPL? So we're looking at a surfing mentality here. The tech waves just keep coming, and IoT is a big one. So changing needs makes us have to be disruptive, and we want to disrupt ourselves, so that not only can we surf the waves, but so can our rovers. So when we find tons of water on Europa, maybe our rover will surf it. Anybody know what Europa is? Yeah, it's a moon of Jupiter. Has lots and lots of water, 3 times as much as Earth. So before we look at what they are, let's look at how we will work. This is really, really key. And I'm very energized about hearing the keynotes, because we share exactly the same opinion. We still use whiteboards, but now the data is locked up in databases. So the way we will work is we will work interacting with it naturally. So we speak to the data, we gesture to it, we touch screens, we blink in our smart AR glasses, soon we'll think. But that triggers into an API into the data that lives in the cloud. So now we can ask questions, and Mick will show some of these things that we're doing. The next phase is when we tie AI into it. AI and machine learning. So we'll be able to ask much better questions and have an intelligent digital assistant working in our behalf in the background, either triggered by us because we're asking questions, or automatically by events. So Lambda plays a big piece in this. So does serverless. And I will not stop calling it serverless and call it function as a service. I thought Andy did a great job with that. So the next technology waves are these. And the big tsunami is built-in intelligence everywhere. And AWS will help us get there. The one we're going to talk about today is, and by the way, you can all participate. We want you to participate. Send an email to techwaves@jpl.nasa.gov. The big one is ubiquitous computing. That's computing everywhere. And it's Internet of Things applied to all devices. It's all built in. So why do we do that? So that the next generation of explorers, they will stand on the shoulder of giants, and they will be able to participate. And they will be able to participate. They will always be connected with each other and their devices. But they all have to work somewhere. So how do you make the office and the buildings and everything else more connected? So to tell us a few examples, Mick Cox is going to take us through some of the experiments that we've done and show us a video, a pretty cool video of a robot.
Thanks, Tom.
Thanks.
So as Tom mentioned, my name's Mick, and I'm here to talk a little bit about our IoT journey at JPL. It's a pretty new journey. It's pretty fresh. We've been on this trail for about a year or two. I'm going to talk first off about some of the things that we're doing in facilities to try and make our buildings smarter so that we can work more effectively. I'm going to talk about some of the intuitive experiences that we're trying to build and where the IoT services fit into those experiences. From there, I'm going to talk about one specific case study where we're using something that I would consider an IoT experience to help people work smarter, better, more efficiently. And then finally, I'm going to show you about how we're trying to dare mighty things with IoT on this planet and elsewhere. So first, talking about that, those facilities IoT challenges, the first one I want to talk about is our conference rooms. One of the things that I think pretty much every enterprise is going to want is a more efficient, more useful conference room. At JPL, I'm sure this is the case other places. People are spending 5-10 minutes at the top of every meeting trying to get the projector on the right input, trying to get the audio working, dialing into the WebEx, et cetera, et cetera. So what we're working towards is making the conference room smart enough to communicate with itself and with the outside world so that you can walk into it, touch a button, speak to Alexa, and now suddenly the conference room is configured for what you need. That goes all the way from the phones to the light bulbs to the projectors to the blinds, all of the in-room devices that should just be communicating with each other. The second way that we're trying to make our conference rooms smarter is by streamlining the use of the conference room itself. So one of the experiments that we did was putting basically a PIR sensor, a motion sensor, on a Raspberry Pi and installing that in a few conference rooms just to see when the conference rooms had movement inside of them. We cross-referenced that with our calendar database, which said when the conference rooms were booked, and we actually found out that of all of the conference rooms that were being booked, about 30% of the time there was nobody actually in the room. So if we could use a device like this, say I have a room booked from 1 to 2, nobody shows up by 1:15, let's just clear it up for the next 45 minutes so somebody else can book and use the room. To make that happen, I want to dive just a little bit into where AWS IoT fits into that. We have the person here at the end who's trying to use the smart devices. We put a couple of echoes into the conference rooms as well as some IoT buttons. So you could walk in and, for instance, hit a button. That fires a Lambda function, which triggers some messages in IoT, which then we have an answering service that lives inside that can cross-reference against our calendar system and control the actual devices that are in the room that may not be on the public internet. From there, with the motion sensors, that's another example of an input. So we've got a motion sensor feeding into AWS Lambda, publishing to IoT, which is then being pushed to RDS or other database services. And again, we're cross-referencing that, using that to store the data about what movement's happening in the conference rooms, and then cross-referencing that against our calendar system. So that's the conference room. The second where we're trying to make our facilities more intelligent are with our machine shops. We have a ton of machine shops at JPL, and they have a ton of different uses. So all the way down from hand tools for building, kind of small, just quick parts, all the way up to something that's actually going to assemble a part that'll wind up on the surface of Mars. So a ton of different tools. These rooms do have the potential for being dangerous. They have saws. We bring in a ton of interns every year. We want to keep doing that, but we need to do it in a safe way. So the way that we want to infuse IoT into this ecosystem to help this is to monitor the usage of these rooms. Are there any rooms that are being overused, underused? A lot of times these are our bottlenecks as well in some of our processes, so we need to make sure that we're providing the most useful, most efficient workspace for people who need to use these facilities. The other place is making sure that we need to make sure that everybody's trained. Again, when we're pulling in a lot of interns, we want interns who have been trained and go through the correct safety procedures to be able to use the equipment without having to jump through a bunch of extra hoops that they might have to today. But we don't want to have any accidents, obviously. So today, we actually do most of this manually with people. We hire people to hang out in these machine shops. If you're a high-altitude balloon scientist who has a PhD, et cetera, you might also just happen to have the lab that you work in under your purview of cleaning up and all that kind of stuff at the end of the day, monitoring that as with human resources, which is not exactly what we want to do. So what we're doing soon is building some smart devices into these rooms to actually control tool by tool or machine by machine access and monitor some usage that way. So the way that we envision doing that is if we have a user who wants to use, say, a drill press or a bandsaw. Everybody at JPL has an RFID tag that we use to get into various buildings and onto lab. So if we use that RFID tag and put something, for instance, like a Raspberry Pi on each bandsaw, now you can walk up to this and tag it. Now it knows, okay, this is Mick, and he wants to use the bandsaw. It's going to publish a message to AWS IOT, which is then publishing a message to one of our internal services, which is querying our safety database and saying, Mick definitely has access to use this bandsaw. So we relay that back to the device itself, and then that device turns on the bandsaw for me to use. Now that is sort of a gateway for making sure that only the correct people are using the equipment. We also want to make it easier for the people to use. So in addition to that, we're actually putting a couple of cameras on the Raspberry Pis as well with kind of a foot switch underneath the bench that will take pictures and start time lapses and that sort of thing, which we then save to S3 so that the engineers can go back later and see pictures and time lapses of what they were building at the time. Which brings me to the third facilities one, which is parking. Embarrassingly enough, we can land rovers on Mars, but we don't know where to park our employees. So we have a parking problem. The first step to any IoT problem is to measure what you've got. So we don't at all have a solution for this yet, but we're getting there. Our first step in measuring is putting in some sensors under the pavement for entrances and exits for the buildings. We're building it in a modular way so that as soon as we identify exactly the technologies that we want to be using for this, we can actually just patch in different technologies to get us a helpful use case at the end of the day. The next one I want to talk about is more intuitive experiences. We want people, as Tom was saying, to be able to interact with your data in an intuitive way without necessarily needing to know exactly where the data sit and without needing to get through all the security holes to get you access to the data. So the first one I want to talk about is what we call the data wall. This is an experiment that we did with our cybersecurity team. So these are some visualizations that we put up in the Cybersecurity Operations Center. So they have various things coming in real time. They kind of want to monitor what's going on our network, for instance. So these are visualizations there. We built in some voice control to this. So this sits up on a wall in their conference trailer, in their trailer, where they're kind of monitoring exactly. Let me show you exactly what that looks like once you add voice to it. Or maybe I click it myself. We're not actually going to have audio on this. So what I'm saying is, Alexa, turn on the Apple TV. So now Alexa turns on the Apple TV. It's going to have the data wall on it. I'll say, Alexa, open data wall. So the data wall skill is open. I say, expand the VPN globe. And it pulls up the VPN globe. I say, go back. And she says, OK, I've contracted that. I say, expand incidents. I want to look at the incidents tile. She says, expanded. I say, now of those incidents, I only want to see category 7 incidents, the really important ones. So it filters that. OK, show me category 1 incidents, only the things that aren't that important. And it'll change and show me that. So trying to build in, with IoT devices, the more intuitive experiences into your data really optimizes the way that you're interacting with the data themselves. So the way that we built this, it's actually fairly simple. As Michael and Brett were mentioning, AWS IoT is only one part in this whole puzzle, but the interaction of all these different services working together is really what gets us the good end user experience. So the commands that I'm speaking to Alexa, of course, run to Lambda as the backend for any Alexa skill, publish messages to AWS IoT. Now from there, internally, you can imagine we don't want to just be streaming our cybersecurity data everywhere across the public cloud. So we actually have answering services that sit inside monitoring AWS IoT. And so if it sees that I've asked an Alexa question from an authenticated user, It'll actually query the internal database in a way that it knows how for some data to tell you back, for instance, there have been this many attacks on the firewall or something like that. And then as well as publishing those messages to the screen themselves, which makes the things expand and contract and that sort of thing. It's worth mentioning here as well that Alexa lives in the public cloud. Lambda and IoT live in the public cloud right now. We keep most of our answering services inside the firewall, so we don't actually have many of these devices on our internal corporate network for safety concerns right now. The next intuitive experience I want to talk about a little bit is just with informational NFC tags. We have these little stickers, the NFC stickers. We slap them on pieces of interest around the lab. You can walk up with your phone and just tap it without having an app or anything installed. It'll pull up a website with some information or a picture or something like that on your phone. By the way, this is served with S3, for instance. So some of the IoT experiences may not even necessarily need to use AWS IoT, the service itself. You can use some of the other services around to build that experience. From here, I want to talk about our acquisition intelligent assistant. Now, this is a case study for something that we did with our acquisition division. We have hundreds of people working in acquisitions. They try and interface with dozens of data sources on a daily basis over literally trillions of records. And they're trying to correlate a bunch of these data, and make use of it and answer menial questions for the most part. Some acquisitions professionals might have to answer questions like, what was the last subcontract we did with Lockheed? What's the associated purchase order number on this subcontract, things like that. You might get asked this question 30 or 40 times in a day, so saving 4 or 5 seconds or a minute is huge on these questions. So what do we want to build? We basically didn't want to build an AI that was going to come down and wipe out everybody, right? What we wanted to build was, we took the AI and moved it to IA, and what we're calling the intelligent assistant, so that there's a robot that's basically working with the user to build a more useful interface. And the vision statement is here: a trusted digital assistant that is working alongside the user and transforming that digital data into valuable information and effective decisions. And a lot of that interaction is actually going to come from the IoT space. So our experiment was to create a proof of concept using some intuitive interface into the existing acquisition data sources in order to improve the efficiency, reduce the training time necessary to interact with the data, and increase the job satisfaction. So the way that we did that was actually with Alexa and a custom Alexa skill. I'll show you here the proof of concept. What you're looking at, again, I guess we don't have audio, but that's okay. On the top left, this is the same person doing the same task 3 different ways. On the top left is with the proof of concept, the very first version of the intelligent assistant that we built with Alexa. And then on the bottom left is the fastest way that she was ever able to do it with the old system, logging into the system herself. And then the bottom right is her doing the exact same task, but the longest way. So for instance, I think she forgot what her password was. It was the answer that once she got the password, she logged into the system, the answer wasn't in that system, so she had to log out of that, log into a different system, different password, had to remember that password, the whole thing. So you can see on the exact same task, if you can improve the interface to your data, you can save your operators a whole bunch of time. Now, I'll give you a spoiler alert, she goes on for a good while. Yeah, the fastest she was ever able to do it was about 3 times as long, and then this one took 1.5 minutes or so without that. So these were the 11 questions that we actually wound up trying to answer with our acquisitions team. They came to us with 11 questions and said, we want to be able to answer these in a more intuitive way. So the orange bars is the amount of time it took before we implemented the intelligent assistant. The blue bars is the amount of time it took after. You can see that across the board for the 11 questions that we had, all of them were faster. So we literally walked up to users, said, what's the associated purchase order for subcontract? 1, 2, 3, go. And just timed them doing it. We gave them an Alexa. We said, the first step is say, Alexa, open acquisition. And then I want you to figure out what the associated purchase order is for this subcontract number. No previous training other than that. Put it down, and these were the results, the average results on that. So it's amazing. It's grown since then. It's unfortunate we won't have volume on this. I should have thought about that. But we have, in addition to just speaking to it and getting questions back, the users started asking for interaction with the screens as well. So similar to what we were doing with the data wall, you can now ask the acquisitions Alexa skill to do things on your monitor itself. So we have a companion desktop app that you install, log into it, it runs in the background, and now when you're interacting with the skill, so I'm asking some normal questions about the skill there, But in addition, you can say stuff like open up acquisition instruction 1.1, which is an instructional document about how to get some chunk of your job done. Maybe I did more demoing at the beginning than I thought I did. So for instance, I'm saying open acquisition instruction 1.1, and it pops up on the screen. Open up this other acquisition instruction, or open up my PowerPoint presentation, and that'll pop up. Take me to my dashboard, right? Take me to this website, and it can open that in your default web browser. So we found that the hybrid approach between the new IoT and the old way of doing things is often very powerful as well. In addition to this, speaking to the analytics side, you want to be measuring everything that we're doing even when you're creating your own IoT experience, right? We want to measure everything that's occurring so that we can try and improve it. This is an example of some of the data that we're pulling out of that Alexa skill, just so that we can understand what people are asking for and improve the experience. The first time that we built the skill, those 11 questions, they came to me, they said, here are the 11 questions, and here are the databases for how you answer those 11 questions. I said, great. I spent a day, built the Alexa skill, gave it back to them, and all the users came back to me and said, this thing is terrible, we don't like it at all, it doesn't work. It's exactly what you asked for. So I sat down with some of the users and watch the way they interact with it, and they're not going to ask exactly the 11 questions that you gave me. Instead, they're going to say something like, what can I ask you? Or I have a question about a requisition, or these kind of things. Never mind, I want to talk about a subcontract, right? Something like that I wasn't prepared for. So I actually took that opportunity to completely rewrite the entire skill, give it a guided conversational flow, assuming that the user was going to say literally anything and we had to handle it. It's worth pointing out, maybe this has a laser pointer that works. So this chunk here, this is a success rate. So we take a measure with every question that was asked to the skill of whether or not we returned an answer that we think is the correct answer. And this is averaged over the course of an hour, I believe. So you can see it jumps all over the place. 1 would be perfect. 0 would be we never returned anything in that hour that we thought was useful. And so for the early chunk, this is when the users were saying this doesn't work at all. And you can see right here that obviously is not working for people very well. Right here on that little flat bar is where we implemented that conversational flow where it's actually directing the users through. So I say, I have a question about a requisition. And the skill will say, okay, I can answer this or this, or if you want something else, just say something else. Okay, something else. What do you want to know? And it tries to match keywords and that sort of thing. So it tries to guide you through it. You can see after that, the average is much, much higher. The setup for this is pretty similar to what we saw with the data wall. Basically, the Alexa skill goes to Lambda, goes to IoT. We have the answering service communicating internally with our databases and then spitting out the voice responses as well as putting information out on the companion app. But in addition to that, with the analytics that you just saw, with AWS IoT, we're actually logging most of those queries into RDS to keep track of everything that's there. And using, for instance, API Gateway and Lambda again to pull some of the information back out and interact with it. And the last thing I want to talk about today, is how we're trying to dare mighty things. That's JPL's unofficial mantra with IoT in the future. Last year in the State of the Union, we talked a little bit about Rovi. Rovi was JPL's outreach rover, and we talked about how we used Amazon Lex to give it a voice. So you could, in a school, you could give a microphone to a kid and they could have a conversation with the robot. And then they could also tell it to drive and turn left and follow me, and it would use the cameras on board to follow you around. This year, we're talking about something a little bit different, which was our open source rover. So we actually created a new rover from the ground up out of consumer off-the-shelf components for a price point of about $2,500. You can go and buy all these components, and then we're releasing an instruction list for how to build them. So with that, I'm going to show you this architectural diagram, and then we'll get into the fun video. The top picture there, the black one, is that open source rover that we were talking about. But I want to show you a video of how we're actually using that with AWS IoT. If I can remember my password. So my name is Mick, and today we're going to show you that diverse robotic swarm that Tom was talking about. Last year, we showed Rovi, JPL's outreach rover. We used Amazon Lex to give it a voice. We used AWS Greengrass to help it interact with itself and its environment offline and online. This year, we're announcing a new robot, the open source rover. The open source rover is built out of about $2,500 worth of components, and all of those components are available from different distributors online. They're all off-the-shelf parts. Its brain is a Raspberry Pi, and we're going to be open sourcing the build instructions and the parts list for how to build this. So high school robotics clubs, individuals, anybody can pick up the parts themselves and then build it themselves as well. But today, the rover is going to help us execute the NASA Mars mission and find life on Mars, or on this Mars substitute. So with that, I'll let the rover introduce itself.
I am JPL's open source rover. Today, I will be trying to find life on this stage just like JPL does every day on Mars.
So today, as the rover said, she's going to help us find life on Mars on this very stage. The way that we're going to do that on the rover is a green grass core. So the rover, the Raspberry Pi, is functioning as the middle ground higher brain, and it's going to be communicating with her other smaller friends that we'll introduce in a minute. The smaller friends have microcontrollers on board, which are not powerful enough to run something like Greengrass out of the box. But now, thanks to Amazon free RTOS, we can get Greengrass onto much smaller devices, and therefore get the much smaller devices into the system at almost no additional software cost to us. So with that, we're going to send the rover out to look for some life.
That wall looks like it might be too high for me to get over. Deploying the wall climber.
So the wall is too high for the rover to get over. What we need is one of those friends, the wall climber. So the wall climber, which we're deploying now, is powered only by a microcontroller. What you're seeing on the screen is a live video feed from the climber as it's climbing up over the top. And you're also seeing its wheel speeds on the right and the left, as well as its pitch with respect to the horizontal. And you're seeing that in real time. So now you see as it popped over the top, you see those two targets down there. We're streaming the telemetry with Amazon free RTOS from the microcontroller to the Raspberry Pi on the Greengrass core, the open source rover. So we'll see what this climber found.
The climber has detected some areas behind the wall that may contain life. Deploying puffers to investigate.
So now we're going to show two of the other friends that the rover brought along today. As the climber mentioned, it sees those two areas behind this wall that we want to check out. They might have life behind there, but the open source rover is too tall to get under the hole. So we've deployed the puffers to get in under that tunnel, and we'll see what they go and find. Once again, these puffers are running very small, very constrained microcontrollers on board, which wouldn't normally be powerful enough to do the streaming of telemetry directly back to the public internet. So instead, they're running Amazon free RTOS and streaming back to the core, the rover, which is doing the processing and aggregation that you're seeing on the screen. So Puffer 1 has gotten to its target.
Puffer number 1 reached its target and has found no signs of Martian life.
So you see that on the top. Now on the bottom, though,
Number 2 has gotten stuck. Rerouting Puffer number 1 to investigate the second target.
unfortunately, Puffer number 2, the blue one, has gotten stuck. So Puffer 1 has to take over the job that Puffer 2 was going to do. And it's going to go see what's behind target 2. And now that Puffer 2 is there, we'll see what it found.
Puffer has discovered something interesting. Analyzing image.
It's going to analyze, see what we have.
Martian detected.
And it found a Martian. So that's actually what we showed in the... I forgot it did that. So that's what we showed in the IoT State of the Union yesterday. We'll show, I want to put up the architecture diagram here quickly to reiterate what's happening. The Greengrass core is a Raspberry Pi, so there's just enough compute there in order to function as a Greengrass core. Those individual smaller devices are both mass and size constrained, and they're only little microcontrollers on board. It doesn't do any processing power there whatsoever. So we're actually streaming back via Amazon free RTOS directly from the microcontroller over a Wi-Fi chip back to the core, all of the telemetry that's being collected in real time. From there, the core is analyzing it and then displaying it on the screen. So this is an example of how we're trying to take IoT from the buildings inside and the facilities and everything like that on Earth and deploy it in other places in space as well. Thank you very much.
So now we're over. Everybody please fill out your surveys, as well as if you're interested in the builders space over in the quad, you can see these demos as well as many other demos of the different things we spoke about. And hopefully you had some interesting insights from the persona and the systems and the perspectives we shared today. So thank you very much.
Thank you, everyone.